About 66 million years ago, a global catastrophe occurred that led to the extinction of the dinosaurs that ruled our planet for 180 million years. This catastrophe is believed to have been caused by the impact of a giant asteroid that collided with the Earth in what is now Mexico. At the time of the collision, about 75% of all living things on the planet, including dinosaurs, died out suddenly. The Earth went through a period of global change and evolution after the extinction of the dinosaurs. The extinction of the dinosaurs gave mammals and other groups of organisms a chance to evolve and dominate and helped shape the modern ecosystems we see today. These events were important milestones in the history of our planet and played a crucial role in shaping the modern biosphere. Imagine Earth populated by various species of dinosaurs that ruled its surface for millions of years. However, approximately 65 million years ago, at the boundary between the Cretaceous and Paleogene periods, a terrible event occurred. 3/4 of all the diversity of life on Earth disappeared, and virtually all animals weighing more than 25 kilograms became victims of this catastrophe. This moment in the planet's history marked the transition from the Mesozoic era to the Cenozoic era, which continues to exist to this day. The Cenozoic era includes 3 different periods, distinguished by both climate conditions and the diversity of living organisms. The first period, the Paleogene, was a lengthy period extending from approximately 66 million years ago to around 23 million years ago. After the meteorite impact, a series of catastrophic events occurred, such as fires, the release of dust and aerosols into the atmosphere, and changes in the composition of gases in the atmosphere. These events caused a brief period of warming and global climatic chaos. As the atmosphere cleared and stabilized, a cooling period set in. Thus, at the beginning of the Paleogene period, the climate was chaotic and unstable, with brief warming, but then followed a long and gradual cooling phase that dominated most of the Paleogene. At the beginning of this cooling phase, the climate became cooler and less humid, affecting ecosystems and the evolution of life on Earth. The geography of Earth also underwent significant changes. One of the most important processes during this time was the divergence of continents. The supercontinent Pangaea, which existed in previous eras, continued to break apart into modern continents and oceans. This process included the separation between North America and Eurasia, eventually forming the Atlantic Ocean. These geographical changes had a significant impact on climate, ecosystems, and the evolution of living organisms at the beginning of the Paleogene period. The Paleogene period is divided into 3 periods with different geological characteristics, flora and fauna, and varying climates. The Paleocene is an early period that lasted for about 10 million years. The average global temperature during the Paleocene was approximately 25 degrees Celsius, and it featured a humid, tropical, and subtropical climate with forests covering the entire planet, including the polar regions. Conifers comprise the majority of the tree species, followed by broadleaf trees. After the extinction of large dinosaurs and other animals weighing more than 25 kilograms, forests became denser and open areas became scarce. This posed challenges for plants as a significant amount of sunlight couldn't penetrate through the dense forest. Consequently, plants began adapting to these new conditions. Some plants became parasitic, while others grew taller to reach sunlight. With the extinction of a large number of reptiles, numerous vacant ecological niches were created, and new species of mammals began to occupy them. In the first half of the Paleocene, the effects of the catastrophe were still evident, and the fauna was characterized by small mammals and generally diminutive animals. The Paleocene marked a time when mammals flourished. During this period, miacids, primitive predatory mammals believed to be the ancestors of all modern predatory animals existed. It is also probable that the ancestors of ancient whales, such as members of the hippopotamus family, originated from even-toed ungulates. Ancient whales possessed hind limbs, unlike their modern counterparts. Initially, they likely lived on land but gradually transitioned to an aquatic lifestyle as time passed. The Eocene is the next period in Earth's geological history, lasting for approximately 22 million years. The Eocene witnessed significant geological processes, including active mountain building, which led to the formation of notable mountain ranges such as the Himalayas and the Alps. The Eocene began with an amazing period of warmth, but around 49 million years ago, there was a dramatic cooling caused by the mass spread of the aquatic fern Azolla. At the outset of the Eocene, the continent of Antarctica was covered in tropical forests, but by the end of the epoch, ice caps started to form on this continent. The Eocene world was inhabited by diverse animals, including various bird species, reptiles, and mammals. This time also marked the emergence of new mammal species, such as even-toed ungulates, odd-toed ungulates, and primates, which adapted to changing environmental conditions. Particularly interesting was the fact that many of these mammals were smaller in size compared to their ancestors, likely as an adaptation to cope with climate changes. Changes also occurred in marine ecosystems during the Eocene. The early cetaceans slowly adapted to aquatic life, and marine life became more diverse, especially in South Asia and the southeastern United States. The Oligocene is the last epoch of the Paleogene period. It began about 33.9 million years ago and lasted for approximately 11 million years. This epoch is characterized by a cooling climate, during which Antarctica began to be covered by an ice shield, and other continents became colder and drier. The gradual cooling led to a reduction of forests in the tropics and an expansion of forests in northern latitudes. As a result of climate changes at the end of the Eocene, many ancient mammal families became extinct. They were replaced by new species of animals, including the direct ancestors of some modern mammals such as rhinoceroses, horses, pigs, camels, and rabbits. In the forests and wooded steppes of Asia during the mid-Oligocene, the so-called Indricotherium fauna emerged. Indricotheres were among the largest terrestrial mammals ever to inhabit the Earth. Some members of this group could reach lengths of over 5 meters and weigh up to 15 tons, rivaling the size of many dinosaurs. Indricotheres had long necks, making them resemble modern giraffes. This anatomical feature likely allowed them to reach food on tall trees. Indricotheres had massive heads with powerful jaws, indicating that they probably fed on coarse plant material. They went extinct about 23 million years ago due to climate change and changes in vegetation. Their disappearance may have been related to competition with other herbivorous mammals and a decrease in food availability. Among mammals, carnivorous predators like entelodonts continued to emerge. Entelodonts were a group of even-toed ungulate mammals that had distinctive features setting them apart from modern pigs. They were more carnivorous in their lifestyle and belonged to the suborder Suina. Research has shown that they had closer ties to hippos and even cetaceans than to modern pigs. The largest representatives of this group reached sizes comparable to hippos, with a shoulder height of up to 200 centimeters, a weight of around a ton, and a skull length of about 100 centimeters. As a result of ongoing continental drift, South America and Australia became completely isolated from the rest of the world. Over time, these island continents developed unique fauna, including marsupial mammals and other endemic animals. The next significant period in Earth's history was the Neogene, which began approximately 23 million years ago and ended just 2.5 million years ago. The Neogene period was characterized by active geological processes that led to changes in the arrangement of continents and the formation of modern continents and oceans. Similar to the previous Paleogene, during the Neogene period, there was a trend of global cooling, especially at higher latitudes. Immediately after the Neogene, in the Pleistocene epoch, Earth underwent a series of glacial periods. Throughout the Neogene period, representatives of flora and fauna adapted to new ecological niches that emerged as a result of global cooling. Some mammals, birds, and reptiles evolved to truly impressive sizes. Global climate trends, combined with the spread of various grasses, made the Neogene period a golden age of open prairies and savannas. These extensive grasslands stimulated the evolution of both even-toed ungulates and odd-toed ungulates, including prehistoric horses and camels, as well as deer, pigs, and rhinoceroses. Some of the flying and non-flying bird species during the Neogene were truly massive. For example, Argentavis and Gastornis exceeded 20 kilograms in weight. Throughout most of the Neogene period, giant crocodiles dominated the seas, far exceeding the sizes of their Cretaceous ancestors. In the oceans of the Neogene, life thrived. Prehistoric sharks maintained their position at the top of the marine food chain. For example, the megalodon appeared at the end of the Paleogene and continued its dominance throughout the entire Neogene. From a human perspective, a key stage of the Neogene period was the continuous evolution of primates and hominids. During the Miocene epoch, for a long time, numerous hominid species inhabited both Africa and Eurasia. However, during the subsequent Pliocene period, most of these hominids, including the direct ancestors of modern humans, became concentrated in Africa. It was only after the Neogene period in the Pleistocene epoch that the first members of the Homo genus appeared on Earth. The Anthropocene is the third and most recent period of the Cenozoic era, which began approximately 2.6 million years ago and continues to the present day. It is the shortest period in Earth's geological history, yet it is during the Anthropocene that many of the landscape's current features have taken shape, and numerous significant events have occurred, with the most notable being the ice ages and the emergence of humans. During this geological epoch, ice ages alternated with warmer interglacial periods. Expanding ice sheets covered increasingly larger territories, displacing animals and plants to different regions. Extensive ice sheets formed in Europe, Asia, and North America, creating ice deserts in these regions, with some areas buried under ice layers up to 2 kilometers thick. Interestingly, the climate during this period was generally similar to the modern climate, but the animal world was significantly different. Many species adapted to tundra and steppe regions, as well as South American pampas, disappeared, partially due to climate changes and partly due to ancient human hunting. Examples of extinct species include the glyptodon, giant saber-toothed cat, megatherium sloths, and many others. The Eurasian tundra and partially Alaska lost animals such as mammoths, woolly rhinoceroses, Irish elk, cave bears, and cave lions. Moreover, there were significant changes in the composition of the human species. Neanderthals gave way to Cro-Magnons, intermingling with them or possibly facing extinction. During this period, several species of ancient humans coexisted on Earth. One of the most well-known is Homo erectus. These individuals appeared around 2 million years ago and lived in different climatic conditions, covering a vast territory, including Africa and Eurasia. Neanderthals, on the other hand, inhabited Europe and Western Asia approximately 400,000 years ago and disappeared around 40,000 years ago. They shared some physical characteristics with modern humans. Modern humans, Homo sapiens, emerged approximately 300,000 years ago in Africa. They proved to be quite successful, spreading across the world and eventually displacing other species of ancient humans. These different species of ancient humans made their contributions to the history and environment of our planet, each with their unique characteristics and impact. Around 70 years ago, the climate began to warm slightly, sometimes attributed to human industrial activities, possibly causing what is known as global warming. North American and Eurasian continental ice sheets melted, the Arctic ice cap broke up, and many mountain ice sheets ceased to exist. In the 20th century, genetics and genetic engineering began to develop. Studying the geological history of Earth from the moment of the Cretaceous-Paleogene Extinction event to the Anthropocene period allows us to gain a deeper understanding of the evolution of our planet and its environment. One of the key lessons from this research is the demonstration of the variability of climate and ecosystems on Earth. We can observe how our planet has experienced periods of global warming and cooling as well as ice ages. These climate changes have had a significant impact on the diversity of life on Earth, leading to the extinction of some species and the emergence of new ones. The mass extinction associated with the Cretaceous-Paleogene event reminds us of the fragility of biological diversity and the need to preserve it. It also serves as a reminder of how unpredictable external events can be, capable of influencing the planet's living nature. Thank you for your attention and the interesting time spent together. If you enjoyed this journey, don't forget to like and subscribe to our channel for more exciting research and educational content.